Can you hear my voice?
Can, madam.
Can, alright. Okay, what do I want to say to you? Bismillahirrahmanirrahim. Salatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabbihi ajma'in. Okay, so today we are going to learn about lab 11. Okay, salah. Okay, and then before we start with lab 11, you can also look at your assessment, and you would see the marks for your midterm has been graded. Okay, and then you can just add with your quiz, so you would have your 25%. Okay, so for your COA subjects. You can see on your assessment with the marks, okay, your assessments and then your midterm, and then I'm not sure. That should be. Okay, you can see on the review. Okay, on the review, when you open the midterm test, you would see your marks on the review section. Okay, so that's for your midterm test. And then for your project, okay, for your project, let me share my screen. Okay, so for your project, you can see there's a group, okay, that has been chosen for you. And then if you want to see who is your group member, just click the show group members, and then you would see there your names. Okay, and then decide with your group teams. Okay, what is when do you want to present your project? Okay, I'll give you like 30 minutes for each of your teams to choose, okay, the time slot. Just look at the responses and also the limit. Okay, so usually I would assign 4%. Okay, 4% at the maximum, and the minimum is like 3. Okay, so those who have selected the time slot, you would see there's a full there. So choose the best time for you to present. And also, I think on the Tuesday, okay, I've checked on the timetable. You have like a 4 to 6 that is free for your what I mean is your timetable on the FTMK website. Okay, it should be empty, but if you are you can select that part first. Okay, so give the other slot to the to group 1, because they don't have much time slot that they can choose. Right, that is for presentation. And then during week 14 also, okay, I would write the we would do the lab test, okay, during the week 14. Okay, so it's during your lab session. I would not do on other other times. Okay, so that so that I can invigilate. Okay, I can see what you have been doing. Alright, so that is for the next assessment. Okay, so tomorrow I would try to finish all the lecture slides. Okay, if I can. Okay, but if not, if we did not finish it, then maybe we can try to finish it next 2 weeks. Right, so let me continue with the lab. Okay, first is that this is the last lab. Okay, the last lab, but I've decided to divide it into 2 parts. Okay, because of there are 4 parts in this lab, but the last part is quite complicated. Okay, so you might want to try to finish up the first 3 parts. Okay, for yourself. So by the end of this section of the practical, so students should be able to understand the MIPS assembly language from samples of programs, and then write the simple assembly programs and transform a simple C++ program to an assembly program code. Okay, so I would give you I will give you a lot of samples of C++ program. Okay, and then you will see how does this C++ program is transformed into a MIPS code. Alright, okay, the first part is that input output. Okay, with the usage of syscall, it means that when you want to write in C++ program, you always need to write cout and cin, right? So the cout and cin, okay, requires the usage of syscall. Okay, usage of the syscall, which is for printing values to a monitor console and reading values from keyboard service. Okay, so it's like, let me draw it for you. Okay, let me show it. Okay, so do remember when when you try to write a code, okay, cout, okay, and then cout, please input positive number. Okay, so you try, actually this command means that you want to display this prompt to the monitor, right? Okay, or maybe to your DOS, on your DOS prompt, right? So we consider the DOS prompt as your monitor, your output. Okay, so you want it to output the text. So what happened is that this is inside the CPU. So there are instructions before that. Okay, there are instructions before that. So CPU is running the coding. Okay, it's run or execute the instruction. Okay, and then when it reached to the cout, okay, so when it reached to the cout, so basically what happened is that it require a console. So which in this case, your monitor. Okay, so it requires something to be displayed on the monitor. So what happened is that they would trigger and interrupt. Okay, they would trigger and interrupt. So why is that? Monitor is an I/O device. Okay, it is an I/O device, a peripheral. Okay, your keyboard, your monitor, your mouse, okay, your hard disk, all of this is an I/O device. So it's outside of the motherboard. So it's only connected by a cable. Okay, so when this I/O device, okay, need to be used during the execution, so the operating system would interrupt the execution. Okay, they would interrupt the execution, stop the current execution, and use the I/O device. Okay, so it will trigger the CPU to stop, and then whatever the instruction here. So for example here, cout input, display this text, right? So they would send out this data, okay, they would send out to this data through the bus, okay, so this is the bus, and then goes to the monitor. Okay, it will go to the monitor and then display the please input blah blah blah. Okay, so once this has been displayed, the interrupt would return back to the CPU. OS will return back the next process to the CPU. So means that, oh okay, it will tell the CPU, now you can continue. You can continue. Okay, so then it will continue with the next one. So for example, if we have cin. Okay, so first is that please input positive number. And then the next is cin. So cin x, for example. So maybe before that we declare int x. So what happened is that when it is cin, it means that a user, okay, needs to press something. Okay, you need to press something. So in this case, an input integer. Okay, you need to input integer. So what happened is that OS would interrupt again. Okay, it would interrupt, okay, to the CPU. Okay, stop the process. Okay, stop the execution. Okay, and then access the IO device. Okay, interrupt and access the IO device. So in this case, they are using the keyboard. Okay, so to interrupt and request to access the keyboard. So in this case, the bus has many routes, you know. So maybe this time it will go to the keyboard. So at this time, the program is waiting for the user to enter the input. Okay, so input maybe certain numbers. Then once they press enter, okay, so the data would go back to the CPU and store into the registers. Okay, so at this time, the OS would return back, okay, the interrupt, okay, so would be ended, okay, and then return back the process to the CPU. And then tell the CPU, okay, now you can continue, okay, with the value that is retrieved from the IO device. Okay, and then they can continue. Okay, maybe ADD, blah, 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 something else. Okay, so this is what we call as interrupt. Okay, they interrupt at the moment, stop the current execution, and then focus on this IO device. Okay, so how do they interrupt? They use the syscall. Okay, they will use the syscall. There are so many interrupt that that is defined in the QtSpim. Okay, but in MIPS, okay, so we only concerned about the cin and cout. So cin and cout. So in this case, we are using the syscall. So the syscall can be used for printing values to a monitor console and reading values from keyboard service. So when we want to request a service, you would need to load a certain code for the syscall to operate. So this code must be loaded into register V0. Okay, so that you can tell the operating system, execute this syscall something something. Okay, and then sometimes you need an argument. Okay, the keyword arguments here means that you have some value to be loaded or to be retrieved or something. Okay, so we use the special purpose registers in MIPS, which is A0 until A3. And then to print the value, put the result in register V0 back again. So actually V here and A here is a special purpose for kernel system. Okay, for kernel system. So especially when we try to access the IO device. Okay, so now let's refer to the C++ files, C++ code. Okay, this coding will try to print the sum of two numbers entered at runtime by the user. So in this case, they are requiring an input from the keyboard. So now, the declaration has T0, T1, and T2 as an integer. And then char, okay, they have a char in string, okay, that contain a buffer string, input a positive integer, okay, with next line, right? And then they would see out. So the way I I show the translation is that they must be in parallel, okay? So one side, this one is referring to this side, like that, okay? But it's not that easy, okay? So sometimes it is somewhere else. Okay, for example, char in string, okay? The string can be declared in under .data. Okay, so let's say if you want to prompt questions, prompt instruction, from an instruction to the user. So you can declare a string. So in string, ASCII Z, input a positive integer, like that. Okay, so do remember, they must have a double quote. Then you can treat this as an ASCII Z. To treat this as a string. Alright. So this is for the declaration of char. And then next is that we display the string. You want to display the string. So you might be wondering or asking me, why are we not you usually put it in under the cout and then just put a double quote, right? Okay, but in the real implementation, when the C++ was compiled and assembled to an object, you may not be able to recognize it. Where does this string would reside to? So I've decided to use the variable. Okay, so use the variable to point where does this string located. Okay, so see out the in string. Okay, so see out in string, the variable in string, so means that it should display input a positive integer. So for this see out, okay, so you would need a syscall. Okay, you need a syscall. So first is that I would load 4 to V0 to tell the assembler, okay, to print string. 4 is print string. Okay, and then load address A0 in string, and then we issue the syscall. So that 3 line here is equivalent to the cout, okay, to the cout only. Alright, so so scroll down, okay, you can see here this one part, okay. First is that load immediate value 4 as a system call code. So refer to this table, the service call code. So look at the print string. We want to print, the prompt is in the string data, right? So you want to print string. So print string system call code is 4. So you would load 4 into V0. Okay, and then look at the argument. If you want to print string, so you need the string data. So load address in string to A0. Okay, using the argument here, so the string must be loaded to A0. So you would load address in string to A0. So in this case, you would load address that points the in string buffer into register A0. So you might be wondering why did you not load the data on the A0? So it's because of string is too long. Okay, it can be a longer size of buffer. So what we can do is that we treat it as an array, okay, as a pointer that point to that string. Okay, so we store it under the int string buffer, right? So we just point the address of int string, okay, store it inside A0. So the A0 will become the base register. It can become a base register. In this case, A0 become a base register for int string. Okay, and then when you type the syscall, so it would call operating system to print the string value. Okay, so operating system would interrupt the processor, okay, and then trigger the IO device, which in this case the console. Okay, the console. So once the system call is selected, load the string buffer address into the register A0. So note that we can use the label as the string address to send the string buffer to the register. So then we can see the prompt input of positive integer on the console. Okay, the next part is the cin. Okay, go to the next line. This is cin. So cin command require also 3 lines. One is li v05 and then syscall and then move t0 v0. So go to the next one. This one. So on page 4, okay. So for cin t0, okay, means that we want to get the number from the user using the keyboard, right? So look at the read integer, okay, because of cin. Cin means you want to read. And then what type of data is the cin? T0 here is an integer. Okay, you already declare it here. T0. So although the assembly code doesn't have any declaration, but when the time it is taken to recognize a data, okay, they would ask, okay, to determine what type. Okay, what type is it for, especially in the syscall. So in this case, for the syscall, to read the data, so they have to specify it, what type of data that they want to read. So here, cin T0, T0 here is an integer. So look at read integer, put a syscall code 5, okay, and then issue the syscall. Okay, when issue the syscall, they would call the operating system to read the integer value from the keyboard. Okay, so when you press a certain number, for example, 10, okay, you press 10 and then press enter. So when you press enter, the value key from the keyboard, okay, the value of 10 that you press under the keyboard will automatically be stored temporarily in V0. Okay, temporary because the V0 would be wiped out if they are going to use back again. So you must move the number from V0 into T0 because of the cin here. Okay, so sometimes you can just put T1, it doesn't matter, but you just need to remember which code is this that you want to refer on the C++ file. Okay, so in this case, you move V0 to T0. Okay, so next would be when you press 10, the 10 will be moved to T0 on your register file. Okay, next is that once we have cin T0, so next is you want to prompt another number, okay, to get the positive number from the user. So in this case, you would cout again. Okay, cout again and then cin. So in this case, they are following the same thing. So cout in string is following the dot data here. So load immediate V04, load address in string, and then we syscall. So on the console, it will display input a positive integer. Okay, but for the next one, cin, they require data to be loaded to the T1. So, following the same previous code for read integer, so we would load 5 to read integer to the register V0. And then we syscall. And then they wait for the user to enter the data. So, let's say I put 20 and then enter. So, the result or the value would be stored temporarily in under the V0. So, you need to move from V0 to another register. Okay, so let's say you copy this, you have to make sure you are using a different register. Because here, they are using a different variable to store the data. And then you add T2, T1, T0. This one is a simple one. And now the next one is to print out the result. Okay, to print out the result, we use move A0, T2, Li, V01 and then syscall. So basically, you want to print out the result of integer T2, right? So go to the next page 5, I think. Yeah. Okay, now you want to see out T2. Okay, so T2 is declared as integer. Okay, so integer means that you want to print integer. Okay, so it must determine what type of data that you want to operate. So in this case, print integer. So since T2 is declared as integer, then we use print integer 1. Okay, so first, before we start with the cout, you would need to move first. Okay, put the sum in register T2 into register A0. Look at the argument here. Look at the argument. Okay, if you want to print, you need some data, okay, to put into the argument A0. So, the result of T2 will be T2 move to A0. Okay, so right now the result is moved in the argument. And then load immediate value 1 as system call code for print integer. You want to print integer, right? So next is that you call the syscall. Okay, put a syscall, then when it is executed, it will call the operating system to print the integer value. And then the last part is to exit. Okay, so to exit the program, we use LIV010. So look at the 10 here, exit 10. No argument, no result, right? Okay, so we just put a syscall. Okay, you will see the result of the syscall when you try to repeat the program many times. Okay, many times. So first, let's copy the codes. Okay, let's copy the codes. Not sure, but I think there must have like some editing that you need to do, you know. Okay, go to the notepad, then paste it. Now you see. Edit first. Okay, edit first. Make sure. Okay. Okay, make sure that they are. Okay, they are on. There are no syntax error. There's no syntax error here. So in string skz, input in positive space, and then backslash like that. Okay, so then syscall. So first is to print out the prompt. Second is to get first number from user, put into T0. So tab. So LIV05 move T0 V0 and then print out prompt syscall. Okay, this one put into register T1. Okay, load immediate 5 and then move to T1. Make sure the 0 is 0 here. Make sure it is 0 so that there is no syntax error. Okay, add and then move and then syscall, exit, okay, syscall. That's it. Okay. Now once you have done, and then save it. Lab 11 1 dash 1 dot esn. You baca. Cannot read. They cannot read it. So okay, now you have saved. So I forgot to put the lab assessment for you. So I'll create the question later on, okay? Okay, now QtSpim. So load the program. Now, you would need two windows. One is the console, and then one is your QtSpim main windows, right? So first is that you just tap this one. Okay, now we are starting on the main coding. Okay, main coding. Or LIV04. So means that you want to print out your string. Okay, so now is load address. Okay, when we load address, you see A0 would contain. Okay, go to the hexadecimal. There you can see an address of .data 1001. So go to the data tab. You would see input a positive integer. Okay. So go to the text and then press F10 again. Now when we pass through the syscall, the console will pop up in front of you. So here it asks input a positive integer. Don't press anything. Okay, it's not the time yet. So now load immediate V05. Now they want to read integer, right? Syscall for read integer. So press F10. So V0 change to 5. And then press F10. Now the console pop up back to you again. So then you can press 20. Okay. And then press enter. The thing with the console here is that they don't have a backspace, you know. So once you have mistaken, accidentally put something else, so it will not detect any error, but it will give you error later on. So what you can do is that you stop everything and restart back again your QtSpim. Okay, so don't backspace. Okay, don't backspace. Just go through, just enter. Okay, so now I have enter, and then it goes to the move T0 V0. Okay, so now the V0 contain 20. It would move to T0. So this is in hexadecimal. Okay, now this one is 20. Okay, now step again. Pop up again. There's the string. There is a string in the displayed. Okay, now press again. Then they were asking another positive integer. So I would press 30, enter. See the change on the V0? Now we need to move. Okay, you need to move. Now 30 is moved to T1. And then next is that they would add. Okay, they would add T1 plus T0 and save it to T2. Okay, they would save it to T2. So T2 contain 50. So next is that we move 50 to A0, the argument. Okay, because of you want to print out. Okay, you want to print integer. Okay, so press F10 again. So this time a syscall. When I press again, now it will pop up the 50. Okay, on the console. So it should be another string that that you can write the sum of something. Okay, the sum of the two numbers is 50. Something like that. But it will be more complicated. So I just make several types of syscall. Okay, several types of syscall that I want to show you. Okay, the last one is the exit. When I press again, I can write again maybe 40 and then something. Okay, this one is 90 and then something. So we can run. Okay, you can just run it. Okay, so the next time when you want to show your project, okay, first is that maybe you want to try the whole system. So maybe you can just press the button run continue here, the play button. So if you just play like that, okay, so you just it's like what you would be doing during when the execution of your C++ program actually. Want to put 15 and then ask again, okay, 20. There, it's like that. Okay, but this time they just stop. They would just stop. We cannot continue. Okay, because of the play button here. Okay, so that is for the usage of syscall. Okay, the usage of syscall. This one is very important because you would need that. Okay, you would need that for a lot of programs, right? During writing the codes. Okay, so now is the branch instruction. So the branch instruction is important because of there's a lot of condition statement that you would need to write during your writing the codes. Okay, so to maintain its simplicity in the MIPS assembly language, there are two types of commonly used conditional branch instructions. So this means you do not have to remember any great variety of special case branching mechanism. So that is for a simple if-else statement. But for a conditional statement that needs to compare, okay, that needs to compare more than, less than, that one will require an extra instruction. Okay. So first is that I will teach you the basic instruction of a branching. So the following one here, see the lab 11.2. Okay, we have the declaration of S0, S1 and then S2. But then one of the variable S2, okay, is initialized with 10. So here on the assembly code, we would or immediate 10 into S2 so that we can initialize the value. Okay, next is that they will require Cin to load into S1. So means that S1 can be any numbers. Okay, so it will go to the if statement. If S is equal to S2, okay, so this is a for true statement or what we call as a true statement. Okay, so true statement means that they just go to the next line. Okay, but if it's false, it is false, they need to jump to else. Okay, they need to jump to else statement. Okay, so that's what we call as a jump case. So in this case, for Cin, okay, we need a user input for integer. So we just follow the syscall code 5 and then put a syscall and then move. Okay, so from V0 to S1. So now we have a value for S1. We need to compare if S1 is equal to S2. Okay, so usually they use the same style. So I would teach you how to write if statement for these two type of branching. Okay, so if S is equal S1 equal to S2. Okay, so this is if condition, right? So you will say if true. Okay, so if this is true, okay, go to next line. Go to next line, which is true statement. So the true statement here is S0 is equal to S1 plus S2. Okay. Next is else. So means that if it's false. So if it's false, go to else statement. Okay, go to else statement. So S0 equal to S1 minus S2. Okay. So I would write it like this. Okay. If false, go to else statement. Okay. So go to next line. So if false, go to jump. I'll write it as jump. Okay, jump to else statement. Alright. So when you want to write, okay, the word of branching means you jump. Okay, branching means you want to jump. So when you branch, okay, there are two types. One is branch equal, one is branch not equal. So either way, they would need a register. A register, register, comma, and then label. Okay, so label to jump. So this is a label to jump. So in this case, if we write if S1 is equal S2, it's supposed to jump to the true, right? But but when you have an else statement here, so it means that you need to write the opposite way of this condition so that you can jump to else. Okay, so you need to write if the statement here use equal, then for your branching, okay, you need to use the opposite, branch not equal, so that you can jump to the else. Okay, so write branch not equal, and then this is S1, this is S2. So means that if S1 is not equal to S2, then we can jump to else. Okay. So means that if, okay, S1 not equal to S2, okay, jump branch, branch, okay, branch to else. Okay, so now it will go to the else. So you would write, okay, this one you tap and then type else. Okay, it is a case sensitive, It's a case sensitive. So if you write it as like this, then you must follow like this also. Okay, so else, and then okay, use this statement S0, S1, and then S2. So sub register S0, register S1, register S2. Okay, so okay, this one S1 else statement. Okay, so else statement. Right. So what about the true statement? So if S1 is equal to S2, okay, so it should not branch. It would not take the branch. Okay. So here you will write, okay, if S1 equal to S2, branch not taken. Okay. Execute true statement. Execute true statement. So you would write, okay, so ADD, and then register S0, register S1, register S2, like that. Okay, so Okay, A. Now I put it there and then if statement. Okay, so let's say branch is not taken. So we would execute the addition at S0, S1 and then S2. So what happened after that is that for a C++, this is considered the end of the if statement. So you would need to jump, okay, outside of the if statement. Okay, you need to exit the if statement. Okay, so means that go to the next main line. For example, maybe x plus plus like that. Doesn't matter, right? Maybe return 0 ke? Okay, maybe return 0 like this. Okay, so after the if statement, okay, after the if statement, you need to skip the else and then go to the next line. Okay, as for the else statement, so if there is nothing, there is no other statement that they need to execute, then they just go to the main code. Okay, they just go to the next line, next line, next line. So basically, they just go to the next line, next line. So do remember, if you don't want to execute the next statement, then you need to jump. Okay, you need to jump. So, okay, put the next line, type J exit like that. Okay, J exit. Okay, so means that you want to exit if body. Okay, exit if body. So here you would write exit. Like that. Exit. Maybe LI register V0, 10. 10, sorry. And then syscall, like that. So just to exit clean it, doesn't matter, just a sample, like that. Alright, so that is for branch not equal. So let's say you still want to use the branch equal. Okay, you want to use the branch equal, So hold on, let me separate this part. And then, okay, now branch equal register S1, register S2, comma. Okay. And then if this is equal, okay, so if this is equal means that you need to execute. The next one is you need to execute the true statement. So you would write true. Okay. You would write true statement. So here you would say if S1 equal to S2, branch to true statement. Okay, branch to true statement. So put a new line and type true. Okay, true. And then add register. Copy je lah. Okay, let me copy this part. Add this one. Like that. Okay, for if statement. Okay, for if statement. And then let's say if, okay, if S1 is not equal, okay, means that when they check, oh, S1 is not equal to S2, means that it should go to the else statement, right? So if S1 is not equal to S2, branch not taken, execute the else statement. So in this case, you copy this part only, sub, okay, sub, there, and then next is to jump. Okay, jump, exit from the body, if body. If else body. Okay, if else body. So last type exit. Type exit. That's all. Okay, for your branching. Okay, so there are two ways actually. One is that you are following the same structure of the if else, except that okay, the condition is changed, not equal, but changed to not equal. The second style is using the same condition, but this time, okay, the structure is different. Okay, true statement is at the bottom. Okay, the else statement is after the branching. Okay, so it's a little bit changes here. You just need to know the flow. You just need to know the flow. Right, so let's write the code. Write the code, test the code, okay? So you can just copy this part, copy this part. Alamak, exit dia salah. Okay, the exit here is should be case sensitive, case sensitive. So control E, alright. Now user input syscall. So this means that you need to ni. Okay, now branch. Okay, branch. Consequence, jump exit. Okay. And then else. S1 minus S2. And then exit. Okay, so like that. Okay, so this is a lab 11. Lab 11 2.asm. Now save this and then run your QtSpim. Okay. Okay, this time around don't play with don't press the button play, it's because of we want to see the flow. Okay, so F10 F10 F10. Now register as 2 contain 10. Okay, so next is that user input for S1. So the first trial, we use the first trial. First trial is value is not the same, value is not the same. So I would type 5 0. Okay, 50. Okay, 50 and then press enter. So now 50 is in V0 and then it would move 50 to S1 here. Okay, now we need to compare. Is S1 is equal and not equal to S2. So when we check, okay, B and E branch not equal, so 17 and 18, S1 is not equal to S2, which is true. So they would jump, okay, they will branch to else. So else position is 12 offset from the current instruction. So 12 means that 12 offset, right? So 12 divided by 4 bytes. So 12 divided by 4 bytes is 3. So you need to jump 3 instruction. 1 and then 2 and then 3. Like that. Okay. So 3 instruction. So it's in the sub. So they need to subtract. Okay, subtract the value. So 50 minus 10. So press F10. S0 should contain 40. Okay, so next exit. So I'll try again. Okay, again the value of S2 is 10. Now the second time they ask for the input from the user. This time I would choose the same value of S2. So I would type 10. Okay, 10. So press enter. Okay, so V0 contain 10 and then move 10 to S1. So S1 will contain 10, right? So next is that we need to check, okay, if S1 is equal to S2, B and E. So S1 is not equal to S2, which is false, okay, because it is equal. So when it is equal, branch not taken, okay, branch not taken. So we should go to the next line. It should go to the next line. So when I press F10, there, it goes to the next line, add. Okay, add. So when I add 10 plus 10, the new value in S0 is 20. Okay, so do remember on the code here, when we are under the, when we did not branch, the coding did not branch, so it must exit. Okay, means that exit from the if else body. So I press enter again. So it should go to the exit. Okay, alamak, tak jumpa. This one should go to this exit here. This one, So again, I forgot about it. Okay, so hold on. Okay, hang. Abort. Okay, now let's run again. Okay, F10. So I'll press 10 and then F10 again. Now, once they have add, they have to jump exit. Okay, they don't want to execute the sub. Okay, so it must jump to the exit here. 44 here. So to the line 44. So there. Okay, it doesn't execute the sub. Okay, so the result maintain 20 there. Then that's it. Okay, so that is for that is for the how to say? Okay, that is for the second section. Okay, for the second section. Right. So next is that when you use the branch not equal, okay, when you use the branch not equal, so you can refer to the branch instruction, okay, whereby this is not unconditional, it's supposed to be conditional, okay. So branch instruction is a conditional where you need to test, okay, where you need to test. So for a jump, they don't need to test, okay, so that's why we call it as unconditional. We just jump to a certain label, okay. But branching means you require some registers to do some comparison, okay. So previously that I have teach you is a branch equal and also branch not equal. But actually we have more than that because of sometimes you want to test if S is more than 0, if S is less or equal than 0, or maybe some immediates, okay, some constants. So maybe we can use set less than. Set less than is less than, okay, to some value under the registers. So set less than register 2, is it less than register 3? So if it's true, okay, if it's true, true means 1. So 1 would be stored into the register destination, okay, and then else. Okay, if it's false, false means 0. So 0 would be stored into the register. Okay, you can use this, okay, to do some operation of, for example, if you want to use like this, if x is less than 5, okay, if x is less than 5, so what you can do is that you can just use set less than immediate and then set less than immediate and then store it on register 0 lah. Like that. And then maybe register padam. Don't want to use that. Okay. So T0 is for temporary S0 is to store the input X, and then Y is to the constant. So in this case, if S0 is less than 5, okay, so if it's true, we store it in T0. Okay, so true, okay, is equal to 1, false is equal to 0. So this value would be stored on T0 like that. So we are using the set less than immediate. Okay, so that is for using less than. But if you want to use greater than, okay, you can use this. Branch greater than 0. Okay, so branch greater than 0. So if S is more than 0, so we jump or we branch to certain label. And then branch on lesser than 0. Okay, lesser than 0. So if it's S is less than or equal to 0, then we also branch. Okay, so we also have a more than, less than. Okay, but only set less than has the method of that can use a constant. They can use constant. Okay, so the usage for this, okay, the usage for this can be seen on the loop instruction. Okay, so I only touch until the loop instruction because for the array you need to master yourself until this loop instruction. Okay, so loop. Okay, loop as in C++ also have 3 types. Okay, I would show you about the C++ first, just a brief one. So we have 3 loops, right? You have for, while, and do while loop. Okay, so each of these loop have some features that is similar. Okay, they have similar features. One is init, branch, update, and consequent. Okay, consequent. So basically, the only difference between these 3 loops is because of the position. Okay, so for loop would execute first the initialization, branching, and update. And then the looping after that will continue with the branching and update. And after that, the consequence. So in this case, the consequence here means your loop statement, your body statement, your loop body statement. Okay, and then for while loop, we start with the initialization. So something like x is equal to 0, or maybe x is equal to 100. And then you would do condition. Okay, condition statement. In this case, branch, branch. So you say while x is less than 5. Macam tu. Okay, or maybe while x is more than 0. Then we run the loop body statement, consequent, the consequent. And then don't forget to update. So what is the usage of the update? To exit the loop. So that's why you need the update here. Okay, so for do while loop, we do the initialization and then start with the do, means that you continue with the consequence. So start with the loop body statement and then update one time. Then you test the branch. You test the condition under the branch. So this is for do while loop. Okay, so for the C++, I would show using the for loop here. For S1 is equal to 0, S2 is equal to 5, S1 is less than S2. So means that if 0 is less than 5, okay, or if, okay, x is less than 5, something like that. And then x plus plus. You will do x plus plus. So here we are using S1 plus plus. And then the body statement for the loop is S1 is equal to S1 plus 0. Okay, so first is that initialization. You would initialize S1 is equal to 0 and then S2 is equal to 5. So at S1, 0, 0, you means that you initialize a 0 to the S1 and then add 0 and 5 to S2. Okay, so to initialize 5 into S2. Okay, so 5 would be S2 will become the sentinel. Sentinel as in the maximum number or the limitation. Okay, and then you would branch. Branch here means that you test the condition. If S1 is less than S2. Okay, if S1 is less than S2, in this case, this is a branch. Okay, so let's try a new one. Okay, copy we start with for S1 equal to 0, comma, S1 equal to 5, and then S2, and then S1 is it less than S2, and then S1 plus plus. Okay, so you would run S1 equal to S1 plus 0. Okay, basically they do nothing. We just add 0. Something add with 0 means do nothing. Okay, it's just we just want to run the looping. You just want to run the loop. Okay, so for this case, for the for loop here, okay, so S1 is equal to 0 and then S2 is equal to 5. That one has been explained here. Add S1 0 0 and then ADDI S2 0, right? Okay, and then for this one, S1 is less than S2. So, if, okay, S1 is less than, okay, if S1 is less than S2, so we cannot use branch. Branch only branch equal and branch not equal. So, we can use the, where is my, ni. Okay, we can use this. Set less than immediate. Okay, set less than and set less than immediate. So in this case, we have okay. So here we have if something less than something, and then we store it on the register destination, right? So here you would say set less than, okay, register destination T0, maybe T0. Okay, just a temporary, just to store the temporary value of the result of the comparison. Okay, so S1, comma, register S2. So here it means if S1 is less than S2, true, if true, okay, if true, T0 is equal to 1. If false, okay, else T0 is equal to 0. Okay, so that is for this command. Okay, for this command. Okay, so we use this and then you need to check. Okay, so if this is true, okay, if this is true, do we need to go inside the looping body? Yes. Okay, you need to go to the looping. So you need to branch. So branch equal. Okay, branch equal. So why do I need to branch equal? It's because of, okay, if is S1, okay, is not less than S2. Okay, if it's not less than S2 means that, for example, at one time S1 become 5. Okay, so if S1 is equal to 5, S2 is equal to 5. So exit loop. You need to exit the loop. So it means that you need to have a condition or branching when Okay, S1 is not less than S2. So that's why we say, okay, so if the SLT return a 0, it means you need to exit the loop. So we use branch equal. So branch equal T0, register 0. So if a value inside T0 is equal to 0, then branch exit. Okay, we will branch exit. Okay, so if it's not, okay, if it's T0 contain 1, means that you are inside the loop body. Okay, you are inside the loop body. So in this case, go back to the coding here. There. Run the consequent. Okay, ADDI S1 S1 0. After that, update. Okay, you need to update ADDI S1 S1 1. So means that you want to update S1 plus plus. And then to make sure you run back the loop body, you need to jump. Okay, you will jump to branch here. So means that you test back again. If S1 is less than S2, save back into T0 like that. Okay, so now let's test the coding. Test the code. Okay. Now, alamak, I have to edit. Okay, now. Branch. Okay, branch go to SLT. Branch equal. ADDI. First statement. ADDI. Jump branch. Exit betul. Okay, so for exit, let's use load immediate register V0 10 and then syscall. Okay, so that there's no error there. So elab 11.3.asm all file save and then load in. Okay, now we can run. Okay, so first is that S1 and S2 contain 0 and 5. So now we test SLT. Between register 17 and 18, okay, 0 is less than 5. Right? When it is true, register 8 will contain 1. Do we need to branch to exit? So if 1 is equal to 0, which is false, so they will go to the next line here. Go to the next line, ADDI, and then update the counter. This time they would need to branch back again. Okay, jump to branch means start back the looping. Okay, continue the looping. Go back to the top, SLT. This time your S1 is 1. Okay, so if 1 is less than 5, true. So your T0 contain 1, right? So now we branch. Again, we do not branch to exit. At S1 become 3. We test again on SLT. If 3 is less than 5, yes, true. So we continue back again. Now S1 is equal to 4. We branch again. So 4 is less than 5. Okay, 4 is less than 5. So now T0 is equal to 1. So we did not take the branch. Now lastly, S1 is equal to 5. So supposedly when we branch back again, okay, we jump to branch back again. So now SLT, register 17 and 18. So S1, is it less than 5? Okay, if 5 is less than 5, so it will become false. See the T0 here? There. So T0 becomes 0, right? Now, when 0 is equal to 0, it should exit and go to this line. Okay, the syscall for exit, right? So there, it goes there. And then exit. So that's it for the looping. Okay, for the looping. Okay, now, okay, so I'll give you an exercise for the lab for today. Okay, I think I'll just take for the lab assessment 11, and then we are done after that. So you can just concentrate on your project. Okay, I think it's enough because I have enough of the lab assessment. I only need 10. Okay, so this is an extra only. So for those who did not manage to submit the previous one. Alright. Hold on. Let me. Okay, so basically you just need to run the code. Okay, you just need to combine these two. Okay, branching and also using the syscall code. So this time I'll give you different questions. Okay, I'll give you different questions than the others, so that you would have a different type of question, so you can practice with the others. Okay, with the constant. Okay, then the program will add for. Taklah, itu yang susah-susah tu later on lab test I can give you. Okay, should be okay. So 16, 23 next week. Okay, and then restrict access for S1G2. Okay, right. Okay, so look at the week 11. There is a lab assessment 11. To write a program that takes an integer and compare it with constant 20. If the input is less, then the program will add 4 to the input. Okay. No. Let me edit back again. Sekejap. Saya nak tukar. Let me change it back again. This time is more than less than. Okay, so that's it. Tak tahulah jadi ke tak coding tu. Jadi je. It's a matter of wording. If you understand the question, then you shouldn't have a problem. Okay, so write a program that takes an integer, okay, from the keyboard, and compares it with constant 20. So if the input is more than 20, then the program will add 4 to the input. If the input is less than 20, then the program will subtract 4 from the input. Okay, that one. Okay, I'll stop the current part, okay, because the next part is the array, you know. This one, I'll explain later on. And also, okay, on week 12, basically, the explanation for the array is under week 12. Okay, so next week I'll just, I have put there the notes for the conditional statements. Okay, the notes for the conditional statements. Okay, so you can continue. Okay, so at the moment, just answer the lab 11. Okay, lab 11. Until 11 o'clock. Okay, I'll be here. Okay, so if you have a problem with the with your codes, just write. Okay, just write it on your notepad and then try to execute. If it's an error, maybe I can check, okay, within this time, within these 35 minutes. Okay, so if it's more than that, then we will stop. Okay, so that's it. I'll mute myself, and then you can just unmute and call me. there's no question and someone have privately messaged me, so that's it. So no question, right? So since there's no questions, so we will end today. Just to remind you, I've been checking the lab assessment, and then some of you did not submit your lab assessments. So you do know that the lab assessment is the only assessment that you can get as easy as it is. So if you did not submit it, so it would affect your whole carry mark. Okay, so that's all for the reminder. Okay, I'll see you tomorrow. Okay, yeah, so we will end today. Okay, so Assalamualaikum warahmatullahi wabarakatuh and bye bye.
Thank you, madam.